everyone, it's Coach Fred here, and today we're going to be talking about compound inequalities. Now, you may remember from class we talked about back when you were trying to go on rides, and these are some of the ride signs at Hershey Park, and could be represented by an inequality. For example, to be a Hershey, to be able to go on the Hershey rides, you had to be between 48 inches to 54 inches. And so we talked a little bit about that in class, but I wanted to formalize compound inequalities. So a compound inequality is an inequality either joined by using the word and or there's a couple other little things that can happen that tell me they're compound inequalities. All right, so let's take a look. Up to now, you've learned about two inequalities that look like this. So if I asked you to graph x is greater than 2, you'd probably put 0 on a number line and the number 2, and you would put an open hole, and you'd graph going to the right. And the solution would be everything going to the right. We actually called that array. All right, x is less than 5. You'd probably graph the number 5. So 2, 3, 4, 5. So here's 5. It says less than, so you'd put an open circle and you'd go everything that way. Well, if I want both x to be greater than 2 and x to be greater than 5, here I'm going to actually put 0 here so it's a little clearer. There's 2, 3, 4, 5. Then it's the solution set that is both of them. So it's the overlapping areas. So x is greater than 2 goes this way. X is less than 5 goes this way. So the answer to this inequality is everything in between them. So it's overlap. Now, I can tell it's an and inequality. Why? Because the word and is there for me. Now, it also could be written as one inequality with the x, the variable, in the middle. With the variable in the middle, it's a little bit easier to see. So here's my 0, here's my 2, here's my 5. I want everything from 2 all the way to 5, and my answer is everything in between. So I like seeing it written like this, and I actually tend to write it like this because I just think it's a little bit easier. But we do need to make sure we understand that and is the overlapping areas of the two separate inequalities. So again, this one was greater than 2, this one was less than 5. So where they overlap is between 2 and 5. Think of it as between. Think of and as between. All right, so how do we solve them when they're a little bit more complicated? All right, so these are the two ways we could have to solve and inequalities. You could be given an inequality, one inequality, with the variable in the middle of two different parts. To solve these, we solve them together. So we would do everything we would if they were individual, but we have to do it to all three parts of the inequality. So for example, I'm going to subtract 4 from the 10, from itself, and from the negative 6. That's going to leave me negative 10 is less than or equal to 2x is less than or equal to 6. Then I'm going to divide all three parts by 2. So that's going to give me negative 5 is less than x, or less than or equal to x, is less than or equal to 3. Now if I want to graph that, it's nice and easy. I have negative 5 and 3, and I want everything in between them. So my solution is all the values of x that are in between negative 5 and 3, just like x is nestled in between negative 5 and 3. All right, but you could also be asked an and inequality with using the word and in two separate inequalities. We just solve them like they're individual inequalities, but we have to remember we're looking for their overlap. So we subtract negative 4. So we have 2x is greater than or equal to 2. Then we divide by 2. We get x is greater than or equal to 1 and subtract 4. Subtract 4, so we get 2x is less than or equal to 6. And so x is less than or equal to 3. All right, so now I graph these. Let's see, I'm going to do them on the same number line. So I've got x is greater than 1. Here's 1. I want closed circle going this way. I've got x is less than 3, so here's 3. And I've got a closed circle going this way. The answer to the inequality is everything in between them, the overlapping area. Why? Because and involves overlap or intersection. All right, hopefully that is a little clear for you. Now let's look at or inequalities. The or means one has to be true or the other has to be true. If I were to ask you to graph y is less than -2, you'd probably put -2 on your number line. You'd put a closed circle and you'd have everything less than that. If I asked you for y is greater than 1, you'd put 1 on your number line, open circle, and you'd have that. If I now make it a compound inequality using the word or, I have both of these on the same number line. So -2 and 1, and I have an open circle from 1. I have a closed circle here. And so my solution could be in either or of the areas. So like -5 could be a solution, or 3 could be a solution. I'm sorry, this is 3. 3 could be a solution, or 4 could be a solution. So anything that is in either of the shaded areas, here and here, and remember the arrow means it's going on forever, would be a solution to an or inequality. Again, the nice thing about these inequalities is that we're going to have two inequalities and we're going to be given the word or. So we solve them just like we do regular inequalities. We add 4 to both sides. We get -3x is greater than 1. We divide by -3. Oops, dividing by negative means I have to reverse the direction of the sign or flip the sign. Or is part of my answer. On this inequality, I'm just going to add 6. So x is greater than 7. So now I've got my graph. I'm going to graph the inequalities. I've got 1/3. I'm going to put right here. I've got 7. So I want x is less than -1/3, or x is greater than 7. So something I could ask you is, what's a possible solution? Well, you could say a possible solution is like -1. That's in the solution area. Or you could say a solution is 8, because those are in one area or the other. So they'd be either here or here. All right, so now we talked about this in class when we were talking about Venn diagrams, but I want you to think about the Venn diagram for a second. We had the Venn diagram. We had this area shaded in blue, and maybe I'll put this one in green. Okay, and inequalities involve the intersection. So that blue part, that part that's in both. So that's why it was the overlapping area, whereas or inequalities involve the union, which means everything else that's not intersecting, okay? So the green area. Okay, and we're going to talk more about that in class tomorrow, and we're going to be using it to practice. All right, guys, hopefully that was helpful. Have a great day.